Hey guys, welcome. This is the video that we're going to start the series off with. It's going to be the essentials of pre-calc. So we're not going super in depth into these topics. This is mainly just going to be outlining what uh, what kind of background we need in order to be successful in this introductory calculus. So we're really just going to be focusing on functions, like the foundations of the functions that you're going to be using. So we'll just talk about like the form that they'll be given in. We'll talk about the elementary functions in this video, and we'll talk about just the idea of like inverse functions and composite functions, because those are really important ideas to understand in order to move forward and be successful in calculus. This isn't meant to be like a series fully explaining pre-calc. If you guys find that you want more detail in that, just comment and maybe I'll make one. But this is really just outlining what you need to know in order to move forward and be successful in calculus. So just to start, just with what is a function. Like the only functions that you're really going to be dealing with in this course are maps from some some set, which is just going to be an open interval of the real line uh, that is just mapping onto the real line. And so all this means is that given some number on the interval, you're getting some other real number as an output. And so let's look at an example. So as an example, just having the function f of x equals x squared. This is like a really basic function that um, hopefully all of you are really familiar with. And so here, the function itself is just the fact that it's something being squared. And I really want to emphasize that these letters are all arbitrary. So some people get really caught up in the variables that we write down, but this X is just a placeholder. This can be anything. This represents the idea that when you put like an input, say 2, that this function evaluated at 2 is just going to be 2 squared. So that x is literally just an input. So you can write f of y. What would that equal? Well, that would just equal y squared. F of question mark is just going to equal question mark squared. I find a lot of people get really tripped up on like just the specific variables that you're using, but it's a variable, which means it can be anything. It varies. So especially when we're going to look at composite functions, because this input, like it can be anything, it can also be in other functions. We can have f of g of x, and this f is also just arbitrary. Like it's just an arbitrary letter that we use to denote functions, because sometimes it'll be g, sometimes it could be g of x, it could be h of t. It doesn't matter. Like, so that's what I really want to stress, is just how arbitrary these are, and just recognizing that for this example, the function is just for having some input that's being squared. And that's how you get the output. And so looking here at this example, the 2 squared, that's equal to 4. So that means if we're going to graph this on an XY plane, that we're going to have a point at the coordinates 2, 4. And so that's really important for what you need to understand about the functions that you're going to be dealing with. And then the form that the functions are going to be written in is what I want to make my next point here, is that these are going to be written in the form, uh, let's say g of x is our function. So g of x is going to equal a f b x minus c plus d. And so what the heck is this? What did I just write here? Like let's look at this. So this f right here, this f is our basic elementary function. So I'll list what the elementary functions are, but it's just um, it's the simplest that you can boil it down to here, and this is going to be what the input is. And the rest of these letters are all just transformations. So it's all just transformations of our elementary function. So this A is going to represent that vertical stretch or reflection. So like if A is negative, then we're reflecting it vertically. If A is above 1, we're stretching it. If it's below, if it's in between 0 and 1, we're compressing it. Um, and then same thing with that B. That B is just that like horizontal compression. And then if it's negative, it's that horizontal flip. This C is how much we're translating it to the right, and the D is how much we're translating it up. And so I'm just gonna share an example of that real quick. I'm just gonna open up Desmos, which is just a really great website that you can all go on to just if you want to like visualize the functions you're dealing with. So let's look at again like that basic y equals x squared. Um, so some functional form that you might be given. Uh, like the elementary function is just something being squared, but it can be say translated as -2 as a flip and a stretch, um, and we'll push it to the right by 3, and then we'll translate it up by 4. And so you can see some function like this, but recognize that that's still just that basic elementary function of the square that's just being shifted and translated. So whenever you see this, whenever you see these multipliers coming in or the stuff inside that function, it's just still important to recognize that this is just a transformation of that basic elementary function. And so that is what's leading into this next topic here. But first, just to emphasize, yeah, so here we had that our function, it looked like f of x to the -2, and then that elementary function was still just something being squared. So this f up here, that's just something being squared, and we just had x translated to the right by 3, and then up by 4. And so that's really just was important to emphasize, is that this is still just that elementary function. This is still just that something being squared, but it's transformed. And so recognizing these forms, this is what it looks like. If we had another one, if we had like h of t equals e to the 3t plus 4, um, then this is another case where we just have that basic elementary function of e, and in its input we have that it's being compressed uh, horizontally and translated this time to the left by 4. But yeah, before we get into too much into that, let's just use that to introduce our next topic and go over what these elementary functions actually are. Um, and so we pretty much like discussed that first one. So just like the polynomial, uh, that's gonna be anything raised to some power. So when you're gonna see, uh, let's do like some examples. Let's say f of z is z squared. Again, where z is just like some random input, but this is just something being squared. We can have another one that's g of t is t to the 5 and and it's really just recognizing that these functions are just that thing being raised to some power. So it's this input up here raised to some power, and they might be transformed in ways like that. Really just when you recognize that you have anything to some power, then that's your elementary function. And so realizing that that input is the thing being raised to that power. And here we're also going to have, so all of these elementary functions, they're going to have inverses as well. I'll explain like the idea of the inverse in a sec, but uh, uh, just for here, that inverse of z will have like the square root of z, and that inverse is really just undoing what that function does. And these are also just those elementary functions. So recognize when you have a square root, the thing inside the square root is your input, and then the square root itself is another, just is one of those elementary functions. You have reciprocal functions, which is really just going to be something in the denominator. So recognizing that the input of the reciprocal is just in the denominator. And then, the properties of these, you'll have like horizontal asymptotes, vertical asymptotes, or points of discontinuity. So this is something that hopefully you're familiar with the properties of this function, but this is what's good just to like recognize like when something is in a denominator, then that's just the input of a reciprocal function. Uh, and then you have your basic trig functions. So really like it all just kind of boils down to sine and cosine, because tan is just sine over cosine, secant is just 1 over cosine. But recognize that whenever you have like just so like these special functions that are listed, just being able to recognize that that is an elementary function, and that like they might be expressed in like these transformation forms. So you can have it stretched out to sine of 3 theta. Sometimes theta is often given as like your input variable. I don't know, +2. Yeah, so just recognizing that that elementary function is the sine, is good to know the properties, especially the graphs. So that's something that that's important to be familiar with. So sine is that odd function, and they alternate between 0 and 1, and they're periodic with a period of 2 pi. So this is sine right here. And so again, this is things that you should be familiar with. I'm just trying to emphasize the importance of recognizing these elementary functions. That's what the purpose of this section is. If you really don't understand the properties of these elementary functions, then that's something that you should stop and really refresh yourself on. But right here, I'm just saying is you should be able to recognize what these functions are. There's also the inverse functions. So sometimes that can be written as sine -1x. So like that -1, that doesn't mean that this is 1 over sine x, because that would just be cosecant. That means that this is the inverse of sines. It's also sometimes written like arc sine. And so those are like the elementary functions there. There's also like your hyperbolic sine and hyperbolic cosine, but yeah, once you're given a special function, just recognizing that input and where that elementary function really falls, that's what's important. The last one, so like there's only 4 that you really need to be able to recognize. The last one is your exponential. And so the input of the exponential is going to be the exponent. So if we have f of t equals e to the t, um, and then the inverse of that is your natural logarithm, which is sometimes just called ln. So inverse is going to be ln t, and so yeah, just make sure that you're able to recognize these functions, these elementary functions in their transformation forms, or in like however they're presented. That's something that I'd say is really important to understand before you move forward in calculus. I'm not really going that much into the properties of them here. Uh, Again, if you want me to make more videos talking about the properties, then sure, like maybe I'll make a series like talking about this in detail. But I'm just saying it's good to recognize, it's important to recognize where these are. So the input of this exponential function is up here in the top. The input of ln is here. It's given like as an input notation. The input of the reciprocal is given like in the denominator, and the input of the polynomial is given as what's underneath the power. So just make sure you can recognize these. That's what's really important. And then, and yeah, because here we can have examples where that input, it's not just a variable, it's another function, which is the composite function, which is the last topic we'll get to today. Um, but but yeah, so let's look, for example, at this inverse. So e of ln t, that's something that's really important. That's what's gonna come up, especially when you're doing derivatives of like different base exponentials or logarithms or stuff. Here, this is just going to equal t, and that's just because these are inverses. So that's really the main point that I just want to stress to make sure everyone understands just what an inverse is that the inverse is just undoing what the function does. So it's giving, so each function so f of x, that'll give you some output y. So that inverse is giving you whatever input gave you y. And so it might not always be unique. And so that's why in cases where like when we had f of x equals x squared, then you need to look at the domain of this function. And so that inverse, let's say if we just restrict this to the positive domain, then we'll have the positive square root. If it's negative, then we'll restrict it to like the negative square root. Uh, but there can only be one output for it to actually be a function. And so yeah, so here we have it like that, and again, yeah, so just the whole point is that these kind of undo each other. So if we have f of f inverse of some variable, that's just going to give you back that input. And so like as an example, like with our squared and square root, and we can do this either way. So if we have f inverse of f of 3, then this is the square root of 3 squared, which is the square root of 9, which is just 3. And so it's just giving us our input back. And so that's really the whole point of what an inverse is. And like I said, this is going to be important when we're dealing with exponentials, because e to the ln of t is just t. Like because the e and the ln cancel out, they undo each other. So it'd be the same thing as if it was done in reverse. It would be ln of e to the t just equals t as well, because they're inverses. And that's what's really important to recognize with that. So make sure you're comfortable with recognizing what the inverse functions are, what's the inverse to each function. And lastly, the thing that was kind of suggested here is when we have an input that is another function itself. So that's called a composite function. So composition. And this is really important. I find a lot of people, when you're doing the chain rule or stuff, they have hard times recognizing when it's composite functions. And so that's why I'm really stressing the emphasis for this video, just saying like, here's what the elementary functions are, here's how to recognize them, and how can you recognize them in a composite function. So a composite function is when you have one function as an input of another. So here it's written f composed with g of, let's say, z. So that's going to equal f, where that input is the function g, z. And so with our example of, let's say, f is e to the f of x is e to the x, then I don't know, g of x is sine x. Then this composition between them, f composed with g of x. I know I did z up here, but again, it's just these variables, like they're just placeholders, because this is f, where its input is g of x, and so our f is this exponential, it's e, and that input of the exponential, remember, it's up here, it's in the exponent. And in this case, that's just the function g of x, which in this case is just sine of x. So we have e to the sine of x. And so, yeah, when you're taking derivatives, it's really important to understand when these composite functions appear. It's really important to be able to recognize them. And so how you do that is you look for those elementary functions. You see, well, we have sine here and we have e here. So this must be, because the input of e is another function. So this is a composite function. And then then you just recognize like what's the inside, what's the outside. So if we were gonna say, if we were just given this, if we were just given, let's say, h of t equals e to the sine x, and we want to figure out what that inside and outside function is, we would just say, well, what's the order of operation when we evaluate it? If we want to figure out what h of 7 is, well, first thing we would need to do is we would need to take the sine, and then after that we input it into the exponential. So that means the sine is our inside function, it's our g, and the exponential is our outside function, that's our f. And so just one last example to really emphasize this. And again, just to emphasize also that these letters are just placeholders, let me just write down f here. F of t equals sine squared t. So this sine squared, that's just shorthand. That's really common used for, you take sine of t and then you square it. So just in case anyone isn't familiar with that notation. And so right here, we recognize that there's two elementary functions going on. We have sine here and we have something being squared. And so we look at what's our inside. Well, the first thing we're doing is we're taking sine. So that's our inside function. That would be like the g. And then after that, we're squaring it. And so that would be our outside function. So since this is labeled F, you'd label it something else like H or U or V or whatever. But yeah, that's what I just emphasize is what's really important is recognizing these composite functions, which is just functions inside functions, recognizing these basic elementary functions and what their inverses are. Yeah, I didn't really go that much into like the properties of them. If you want me to, just yeah, just comment and I'll make another video. But yeah, right here, before you move forward in calculus, you need to be able to do all of these. Make composite functions, recognize composite functions, recognize the inverses, recognize your basic elementary functions, recognize the transformation form, and just knowing what the function is and that these letters are placeholders, that is what is essential before you can move forward in calculus. So if there's some part of this video that you don't fully understand, don't move forward. Stop now and focus on that, because that's what I see is such a big problem. People people don't have a firm grasp on these foundations, and then they move forward and then things just become so much harder and more complicated than they need to be. So really make sure you know everything in this video, and you feel comfortable about it, and then yeah, we can move forward into the actual calculus. So I hope this was clear. I hope this was educational, and that you guys learned something and you feel comfortable with this. And yeah, all right, we're done.